All right, let's get started. Thank you everyone for coming. Pretty good turnout. We slammed 4 pizzas, so that's a record. So welcome to Below Sea Level. I'm not sure which one this is. This may be like the 7th one or so. Me and Aaron Lee, who is not here right now, his dog is sick, started this last year, and the goal is basically just to get together systems programmers in New Orleans, and it's kind of meant to be a place where we can all kind of come together, people who are really experienced, people who are just kind of curious. And I'm excited about this one because it's one of my favorite topics, WebAssembly, and also Dom is going to do, I think, an excellent job of kind of talking about like kind of how it works from a high level and like why you should care, which I think is a really difficult thing to understand if you're reading like blogs and a lot of the literature out there. So that's really exciting. Also, this pizza and everything is sponsored by Delipso, so thank you, Uncle Delipso, for the pizza. Yeah, something. We will have T-shirts. We're working on T-shirts, trying to figure out exactly if we'll just like charge them or maybe you get it as a reward for speaking. So if you're thinking about doing a talk, go ahead. You go. If you're thinking about doing a talk, let me know. Even if you don't have a subject, I can help you figure out a subject. We actually don't think we have anything planned for January yet. So, well, actually, we've been doing some kind of like every other month we'll do like some lightning talks. So we'll probably do that in January if it's not like January 2nd, which might not work. So we'll see. We'll keep you posted on Slack and on the meetup and everything. So today let's get right into it. Today I have Dom Saulet, one of my longtime friends and colleague at Dilipso, and he's got Wasm presentation for you guys. So let's get that started. Where'd my cursor go? If you could keep the mouse up there to the right, just so it doesn't.
Oh, okay.
The thing doesn't kick on.
Are you going to record this as well, right?
Huh? Oh, this is streamed and recorded, so it'll be on YouTube later.
All right. Hello, Below Sea Level. I'm a long-time lurker, first-time speaker, so glad to be here. This is WebAssembly Unpacked, but before we get into the actual unboxing, just a little bit about myself. Dominique Saulet, Dom for short. I'm currently the Director of Product at Dilipso. You might hear that word a lot through this presentation, but we are a company focused on building products and tools to help companies, individuals, and teams take WebAssembly to production and keep it there. Prior to that, I was at a company called Recurly working in the payment tech space, and prior to that at a company local to New Orleans called iSeats, where I spent a big chunk of my career working in travel tech. At Dilipso, we are scattered across the United States. I'm here in the greater New Orleans area with my colleague Ben Eckel and co-host of Below Sea Level. And these are some places you can find me on the internet. And if you're on GitHub and can't find my name, you can look for this avatar. It's pretty prominent. All right, we're back and rolling again. So if you're at this talk, the choice has already been made. You're taking the red pill. Your task is to find out why. But I will ask you to keep an open mind through this talk and challenge your beliefs about what's possible in computing. Let's take this red pill together. Reality might be swirling around for you right now. You've got a lot of questions brewing about the nature of reality. Questions like, why am I forced to write JavaScript for all my browser applications? Why can't I write other languages that I enjoy? Why can't I NPM install in my Ruby applications? Why can't I build a Go module and stuff it in my Python program? And why, with all these SaaS platforms out there, am I forced to put in pull requests and hope they get on some product roadmap and delivered at some point in time? Why can't I just write my own code, push it into that platform, and customize my business logic to my exact requirements? And to that note, why am I writing the same business logic over and over again for all these different platforms and environments? My native mobile apps, my web applications, just feels a bit redundant and inefficient. And for a second, reality comes crashing back in, and we start to remember why these limitations do exist. And a big part of that limitation are the machines. There are so many machines, different shapes and sizes, different CPU architectures. And the challenge, oh, by the way, this cartoon is by Lynn Clark, formerly of Mozilla, now at Fastly. And she does a lot of great code cartoons, a lot of good content on Wasm, highly recommend her. In this cartoon, she's sort of illustrating how machines are sort of like these alien beings. They have their native language, ones and zeros. And our challenge as humans is we don't want to write in ones and zeros. We want to write in our higher level languages, and somehow we need to bridge that gap and communicate with these machines. But the problem gets tougher because on both sides of the equation, the machines don't all speak the same dialect. They like different patterns of ones and zeros, what works for them in their particular situation. And as humans, we like variety too. We have all these different high-level source languages that we use, and we want to use the right tool for the job. Variety is the spice of life. We don't really want to limit ourselves on either end. And you know, new machines to reduce our options. It is to find a way to peacefully coexist. But the machines aren't the only problem. It's also the programs. I like to think of programs as in this abstracted tree, the programs running programs at different levels of governance. And they all have their different ways of interfacing. We've got our operating systems that have different methods of system calls. We've got system libraries to interface with those system calls. We've got our programs running in user space that need to use capabilities within the operating systems. We've got web browsers that are running our JavaScript runtimes, maybe not other runtimes for the other dynamic languages we want. Python runtimes with tons of dependencies, databases. So the problem just gets even more complicated and fragmented with the programs. And that brings us to the question that brought you here. What is WebAssembly? But more importantly, why should you care? This is WebAssembly. This purple box here. Yes, yes. But more specifically, WebAssembly is a compilation target. WebAssembly is portable. WebAssembly is standard. And most importantly, WebAssembly is secure. And WebAssembly is a lot more than this, but I think this is a good place to start and to focus. So let's hit these one by one. Compilation target. What does that mean? Well, WebAssembly is a language. This is another great cartoon by Lynn, where she's showing 3 different representations of the WebAssembly language. The one at the bottom, the text format, is probably going to be most familiar to us as humans. We call this WebAssembly text format, or WAT for short. And this little program is doing something very simple. It's just adding together 2 numbers. But the binary one is the one we're kind of really interested in. This gets us closer to the language of the machines, but it's not quite in any specific dialect for any CPU architecture. But it's kind of almost there, which is nice. Now you can write WAT by hand if you like, and some do, and some enjoy it. But that's not where the real power is. We still want to write in our high-level languages. And so that's where the compilation target comes in. What we really want is I want to write in C, C++, Rust, any other language you might desire. And I want to let the machines, the compilers, do the translation into WebAssembly. And then on the other end, I want to translate from that into a specific machine code dialect. So we can kind of think of WebAssembly as this intermediate representation. And hopefully this graph is looking a lot better than the one we saw in a few slides earlier, that very fragmented graph over there. And so this sort of gets us where we want to go, but we need something to translate from that WebAssembly language into the machine dialect, and that's going to be another program. That's where the WebAssembly runtime comes in. It's going to take this WebAssembly and it's going to get us that next step and translate that code into the specific machine dialect. And the really nice part about this runtime is it can be pretty easily embedded into a host. And by a host, this is just a placeholder for all types of other applications out there. It could be an operating system, it could be a web browser, it could be your application. And this allows us to get these WebAssembly modules closer to the machine, the particular environment that we want, and get that translation to happen. So what we're really looking at here is a lingua franca, if you will, a common language that we can use to bridge between all of our human languages and the machine languages. And what that buys us is the other thing we said WebAssembly was, which was portable. Now I can write once in the language that I want and get that ported anywhere, maybe not everywhere, as long as there's a WebAssembly runtime, which is the little italic there, the little caveat. And maybe at this point you're starting to say, please, keep it to yourself. Maybe you're thinking, I've seen this movie before. There's something for this. Maybe called Java, and certainly it's beyond the scope of this talk to start getting into the itemized differences between WebAssembly and Java, and there's folks that will do that a lot better than I can, and I do have a slide that will point you there. So let's keep our focus still on what WebAssembly is. And so we said portable, we said compilation target, but we also said it was standard. And to me, that's one of the biggest things about this. WebAssembly was created by a group of individuals and companies that provided a uniform standard, something that we can trust, something that isn't going to go away and be pulled out from under us, otherwise known as the W3C, the World Wide Web Consortium. So WebAssembly is a web standard, and that's a great foundation to build on. And the testament to that is the fact that if you've used a major browser in the last several years, you've been a few clicks away from a WebAssembly runtime because it's in all of the major browsers. My colleague Ben Eckel likes to describe this as the sleeping giant. It's just waiting for us to feed it WebAssembly in this browser host. So that's pretty powerful. We also said WebAssembly was secure. And so let's unpack that a little bit. This security comes from the fact that at its core, WebAssembly is just compute. It doesn't have access to the environment by default and where it's running. The WebAssembly runtime and the host that's running that runtime is governing the execution of these WebAssembly modules, and they hold the keys to what that module has access to. So it's essentially running in a sandbox. And we like to think about sandbox as having two kind of main components. One is memory isolation. When the runtime kicks off or executes these modules, it's giving it a very specific slice of memory for which it can operate. And it can't go outside of these boundaries, and the WebAssembly runtime ensures that. So that means if you have another module running in the same process, or you have other processes running in this operating system, or anything else in that environment, the module cannot muck with that stuff. It can't jump into another random memory space and start messing with the machine instructions or data, and that provides a very strong level of security. The second component to this is everything is denied by default. It's just compute, and we can do a lot of use cases with that, but similar to the applications on maybe your phone, it doesn't get access to your camera, it doesn't get access to your GPS just by default. It has to be granted that access selectively on an as-needed basis. And it's the same thing with the WebAssembly runtime. It's restricting access to anything from like network access to the file system, and these things have to be granted to it very selectively. But we want it to have access to these things in certain situations, and that's where imports and exports come. You can basically just think of these as an interface. This is going to allow us to build up a contract between the WebAssembly module and the environment that it's running within. Think of it like, I think more akin to like a REST API. It's not language specific. There are functions with parameters. It's got an output. They've got some names. So we can illustrate that with this diagram, and again, going with the sort of host-guest analogy. And I like to think of these imports and exports from the perspective of the guest, the WebAssembly module. So the exports are the things that it's providing to its host. These are all the functions, the building blocks that I decide as the WebAssembly developer that I want to provide. And then the imports are the things that the host are going to provide to the WebAssembly module. So in this example, we might have a module that exports one function, count vowels. It's going to take some strings and it'll count up the vowels. That's great. But maybe it wants something from the host. And again, the host is in control of whether it provides this or not, but maybe it wants to talk to a machine learning model. So we got a function called predict token. Now, the really cool part about this is we have this separation between the interface and the implementation. So who knows what's behind that predict token interface? The host, the various hosts in which this module might run, can implement this in any number of different ways. Maybe it's a call out to a chat GPT, or maybe it's running a local model within the host itself. So this gives a lot of flexibility on both the host side and the guest side and how it handles the implementation, which speaks back to that whole fragmentation we were talking about. With all these programs and their different interfaces, we can start to smooth out this fragmentation with this mechanism. So let's unpack one of these things. I've been talking about them. The really cool thing about a WebAssembly module is all of this data is packed within the artifact itself, which gives us the ability to dig inside of it and take a look. This is a tool called ModSurfer. It's available out there. You can go and check it out. It's built by dilibso, but effectively what this gives you is X-ray goggles into a WebAssembly module. You can also share them around too, which is kind of cool. So yeah, let's kick off this little demo. I'm going to dig into my WebAssembly stash here, pull out my countvowels.wasm, load that in, and now we can see the source language was Rust. We can see the size. We get this nice manifest of all the imports that it wants from its host. And then, of course, our count vowels function there. And we also get some signature about the function, some data around the parameters and the results that we can expect. We can also see the source code. So here's that WebAssembly text format I was talking about in that human readable form. Obviously, as you can see when I was scrolling, you probably don't want to write that by hand. But another cool thing about ModSurfer is it's using WebAssembly to inspect WebAssembly. This is actually Wasm modules running in a browser, So I think this is all very exciting. I think we're kind of on the cusp of kind of rethinking a lot of things that we've been doing in computing. The first obvious one is the web browsers, which is where WebAssembly sort of started. And going back to that question of why can't I write anything other than JavaScript, I know I'm smoothing over some stuff there, but that was because the web browsers had JavaScript runtimes and not a Python runtime or a Ruby runtime. But as we talked about before, all the major browsers now have a WebAssembly runtime, which means I can inject modules in there as ModSurfer was doing, and the arrows represent those imports and exports. So as long as I open up the capabilities, that module can interact with the JavaScript runtime and with the browser and the capabilities that it provides. So what do we get with this? I think this is illustrated well with this little demo by Epic Games, this Zen Garden, which I think is a fairly nice photorealistic rendering. But this is using WebAssembly and WebGL. Which, this kind of blows my mind. And there's, obviously, if you search the web, you'll find numerous examples of games and applications that are just taking things to another level with these technologies. And so that's pretty cool. But we also talked about another use case where I want to push code into these SaaS platforms out there. Why should I have to use REST APIs and go over the slow networks in order to kind of customize things and leverage these platforms? Well, with a sandbox that can be sort of injected in these multi-tenant platforms, kind of changes the game, because otherwise there's no way in hell I want to run your arbitrary code, because A, I may have multiple tenants running on this platform and I don't want you messing with them. But even if it wasn't multi-tenant, this is my system and I don't want you potentially bringing it down or doing something really nasty. But with these modules running in a sandbox, we can have obviously more certainty, control over these things, but we can take this even to another level. Why not turn it into a marketplace? Why not have a bunch of plugins that a developer ecosystem can be created around and customers can use these things? So take the concept of like the app stores and app marketplaces And this totally turbocharged that at a more granular level with business logic that can be applied to all these different vertical specific SaaS platforms. And that, if you really want to dig deeper into that concept more, I recommend Ben did a great talk on why you need a plugin system, and it really kind of digs more into that concept. To tell you this isn't just smoke and mirrors, if you've heard of Shopify, they are doing exactly this. That is, Shopify functions are built on top of WebAssembly, and it allows developers to write code and push it right into the Shopify platform, in fact, right into the checkout path, where their customers can tailor discount functions and other parts of that checkout to their exact specifications. We also talked about, like, why can't I write some Go and throw it in my Python program? There are companies out there that are writing software development kits. Maybe they write it in JavaScript, and all the JavaScript developers are happy. They have this great package that they can NPM install. But then the Python folks and the Go folks come in and like, I want that too. And either it's just too much work and they're not going to get it, or that's a lot of burden on the company building these software development kits. So why not just have a universal software library that I can inject into all these different language ecosystems and rinse and repeat? I hope these are starting to sound like superpowers. They are to me. We're not done yet. I talked about, like, why am I writing the same business logic and pushing it across to all these different platforms? Why not have a module like this that is really good at image detection? Maybe it's backed by some machine learning module or model or something else. But maybe it's running on all these different types of hardware that have different operating systems. But I just want this one piece of logic to be able to run wherever I need it, maybe even take advantage of some of the capabilities of this specific hardware where it makes sense, and really kind of turbocharge my development for these types of situations. What about databases? Talked about JavaScript in the browser, but sometimes SQL just isn't enough, and seems a little inefficient to be running SQL queries, pulling this data out, maybe running it in some Python program, then pushing it back in. I know there's a lot of good tools out there for stuff like that, but what I really want to do is just write the code right in the database itself. And there are some database engines that do this, you can obviously, but I want to open this up to all the languages. So why not put a WebAssembly engine in my database and then start running some user-defined functions right in line with my SQL query? If you're interested in something like this, we have a colleague at DialibSo, Mohammed Aziz, and he did just this. He wrote a Postgres extension that shoved some WebAssembly in there, and you can write WebAssembly modules as part of your SQL queries. If you want to accelerate that even further, let's talk about the idea of compute over data. We think about data sets are just getting larger and larger and larger, and we've sort of been in this pattern where we want to ship the data to our compute, run some analysis on it, and then maybe ship the result back. But that's a lot of data that's very cumbersome, and there's a lot of legal hairiness around with that too, especially with data residency and portability. So why not take a small compute artifact, send that to the data, and do all the work where the data is? And this project here, Bacalhau, is doing just that with this distributed compute over data platform powered by WebAssembly jobs. All right. Final use case, we could go on and on and on, but blockchains too. Why should I write a smart contract in some very domain-specific language, have that learning curve? I want to write it in any general purpose language and put it on a blockchain. And there are projects like Wasm out there doing exactly this. All right, so that's it for this rabbit hole. We're not going to take you down any further than this. I have sort of glossed over some things, and you may find if you go to work with WebAssembly, you may find certain challenges there, but the good part is this is a thriving and evolving ecosystem. There are companies like DialibSo that are working every day to continue to improve the developer experience and the usability of it. So if you don't want to go too far down the rabbit hole, you don't, because as Blake Ross reminds us, the next big thing is the one that makes the last one usable. So projects like XDism, which is a framework for building with WebAssembly. This is a project, an open source project maintained by DiLibSo with the help and support of a nice, thriving developer ecosystem. This allows you to get up and running with WebAssembly and put it in your application and go from 0 to 60 in a matter of minutes if you follow our quick starts. So hopefully you're feeling like you know some Kung Fu here now, and use it for good. XDism is actually about to hit 1.0 in January, and we are commemorating this with a hackathon that actually started today, and it's going to run through December 21st. And it's pretty simple. Just build something, small or large, with XDism. You can commit your project to a little repository we've set up. I'll show you the details on how to get to it. And then we'll add your name to a check that we are donating to Toys for Tots this year. So feel free, you can scan this QR code or go to this landing page, but it'll give you all the details you need to get involved with this hackathon. And final slide. Here's a bunch of resources that you can check out. A few notables. Obviously, this is ModSurfer, the tool I use to inspect that WebAssembly module. And I highly recommend this Understanding Wasm article. This was actually written by another one of my colleagues at DiLibSo, but he'll take you very deep in a two-parter that even goes through a lot of history of computing and how we ended up with this technology, how it evolved, and he does it with grace, and you'll really appreciate it. And the other one I'll call out, if you really want to get into the nitty-gritty sort of comparison between WebAssembly and Java, Eduardo Vacci has great articles and talks out there that I highly recommend that definitely gets into all that. All right, that's it. Open it up for questions.
You got time for questions if you need some questions.
Yeah.
How does WebAssembly compare or is different to Grail?
Could you repeat the question?
Oh yeah. So the question was, how would we compare WebAssembly to Grail, which I believe is the Java VM that's Grail. Yeah. Yeah, Grail. Yeah, actually, sorry, I'm going to redirect this one to Ben because he's been pretty deep in that.
Yeah,
That's
it has some similarities, but Grail is more like Grail has something called truffle that allows you to like write interpreters really quickly, but it's also not really meant to be like WebAssembly is like meant to be run on the web. It's like meant to be run in a sandbox, and like Grail doesn't. Grail is more like JVM. Like everything has all the capabilities of the system, from my understanding.
Okay.
Yeah, and it's also not really like Grail is not something I would want to embed in my application.
Yeah. I guess I'm thinking from the perspective of like you have the Rust, C, C++, and
Yeah.
going to that. It's like that was my kind of like comparison for.
There is like the original
Similarity,
Grail
sorry,
paper
yeah.
was called like one VM to rule them all or something.
Yeah.
And they have some similar goals, but
Makes
Grail was
sense, yeah.
written, at Oracle with all these specific kind of applications in mind, whereas Wasm was written at Mozilla mostly for the W3C. Like Dom said, it's already in all your phones. It's very lightweight. It's like
Right.
everywhere, and it's a standard that, in theory, like one company controls.
Got it.
Yeah.
So performance of different languages in Wasm, is there like, so like I write the same function in JavaScript and Rust, are they going to perform similarly in Wasm, or the advantages of one particular language or the other are still going to be the same in Wasm?
Yeah, so one of the things I kind of glossed over there is like you probably saw C++ and Rust in a lot of the examples. The language support is obviously still evolving for WebAssembly, in particular with like dynamic languages like JavaScript and Python. This is what I love about WebAssembly. I feel like it's a lot of turducken stuff happening, but instead of it's a bit harder to go from those dynamic languages into like a WebAssembly binary. So what we do is we compile the runtime itself into WebAssembly, inject that JavaScript code or the Python code and then run it in there. So I don't know the benchmarks on this, but I would suspect obviously if you write it in Rust and you just have a pure Wasm binary with no runtime inside of it, it's going to have better performance. So.
Is there like a size limitation?
In terms of the size of the artifact itself, or just?
Well, I don't even know.
Yeah.
Just asking that question.
No, I've seen them get really big. Like you can, I mean, like we said, you can put entire interpreters and runtimes and compile them to WebAssembly. So they can get pretty big. And as far as like the memory space that's allocated to a module, it can keep requesting pages basically. And so those memory sizes can get pretty large as well. Yeah, I don't know exact limits on them, but yeah. Oh, sorry.
So final earlier question about running with Python as opposed to like C or Rust.
Yeah.
If you were to write Python but write it bearing in mind like the variability, so the hard code, like your variable types, your sizes of objects, so it's not so flexible, would that translate to improvement on the other end?
Possibly, maybe when it's executed, it's still going to be running in a Python interpreter compiled to WebAssembly.
Sorry, I missed what you're saying.
Yeah.
Is the idea that you can write something in Python, translate to Wasm, and then shove that into anything else?
Right, so you basically take the Python runtime and then you're taking your actual like high-level source Python code, and that can actually be embedded in like the data section. So that was one thing I didn't talk about with the modules as well, but you can store other data in these WebAssembly modules that you can ship around. So you can actually even do some pre-processing to things like Python and JavaScript and basically like freeze it in the WebAssembly module, and then you can have that interpreter run that code, but it's still running as pure Python or JavaScript inside, basically in the module.
Is your question more about like how there's like assembly script, which is like a sub weird cousin of TypeScript, which is like typed to be able to compile directly to?
If you were to try to like write your code more efficiently, like to
Yeah.
if you know garbage collection isn't
Right.
gonna be there to like take care of it, or it's not gonna compile well, if you write it
Yeah.
to make sure it will compile well.
So you're saying if like you added sort of like type checks and things like that, could you get it to compile to like pure Wasm byte code, the Python itself?
Or
Is that?
better.
Well, maybe like Mojo and those other things kind of
Also,
do
maybe
that,
I'm
right?
misunderstanding. Like, is the idea? It seems like the intent would be not to like write Python code, turn it to Wasm, and then run it in Python. You should write Python code, turn it to Wasm, and then run it into some third environment.
Hmm.
Yeah,
Well,
let's do
so
that.
any performance improvements of your well-typed Python code that made Python run faster on the Python interpreter, that would translate
Yeah.
to Wasm on the Python
Yeah.
interpreter.
Yeah.
But you're not going to get improvements by going to Wasm.
There are some things you can improve, like he was saying. You can. So like he said with grail, right? There's something called truffle, and that's like pre-evaluated dynamic languages. And with Wasm, you can do a similar thing where, like, if you imagine like if you go to a big website and you download a bunch of JavaScript code, it's the same thing with Python. First thing it has to do is parse all that code, compile it, all that stuff. Like you can skip all that. So the runtime performance might not be different, but the startup performance could be way faster because you can it's already evaluated all the code. So there are some tricks.
Yeah.
Is modular and Mojo, do they tie into Wasm at all?
I don't know. That just made me think about that. See, because it seems like it could be something they could do. Yeah.
Mojo is a new Python superset that is going to compile down. To
Oh, interesting.
Mojo.
Okay.
And then
Yeah.
Modular is the company that's like setting up. It's Chris Latner, the guy who wrote Swift
Okay.
And
Yeah.
LLVM, yeah.
in LLVM.
Yeah, that
so
makes
that's a really
sense.
exciting project as well. So I'm curious if
Yeah.
Mojo compiles to WebAssembly.
It should. If it doesn't.
doesn't.
Well, if it uses LLVM,
Yeah.
that's another thing, right? Like LLVM has great Wasm support, so anything that compiles to LLVM, like automatically gets Wasm support, and that's
Yeah.
why like it's really taking off a lot, because a lot of things use the LLVM toolchain. So yeah, probably so.
So this feels like less like this is one translator to rule them all. It's like, oh, how do I, as a C# developer who does not want to touch JavaScript, how do I get my code to run in a web browser or in TypeScript and I want to like have my module run everywhere. Oh, but it's gonna run like shit because it's Inception, not the Matrix. You know.
I love continuing.
Yeah, I know. It's such a good analogy for this world, I feel like. But yeah, I mean, it just depends, I think, on the use case and what you're after, and do you need the performance or you need more of the portability? Like, yeah, that's.
Well, it also feels like it frees up architecture designers who don't have to stick with x86 or ARM. If
Yeah.
you can now
Yeah.
build a new machine architecture that just runs Wasm, then we can get new architectures that
Yeah.
have a whole new role.
Absolutely, absolutely. Yeah, I mean, a lot of people even describe Wasm as a computer, a virtual computer. So yeah, if you even had hardware that was more tied to it, it could be really interesting.
So if we like shove like Wasm into like a Docker container or a Kubernetes container, would that just like be an easy gloss over that? And then like JavaScript or Python is going to perform how it performed, but it's not going to be degraded by having that abstraction of Wasm in between that and like the hypervisor before it goes to the mouth.
Yeah, no, I don't think it would. No. Yeah.
Speaking of performance, when you were showing like kind of you could put it on devices and stuff like that. You have like the camera, the CCTV camera,
Yeah.
and the Cybertruck. So.
Oh, is that what that was? Oh, okay. I don't know.
So for the like when it comes to Wasm, and especially for like a real-time application.
Yeah.
What's kind of because you have to put you need a runtime, right?
Yeah.
And so is there like I guess it's like two things like how does it perform now on like real-time kind of systems, and side question, is there like a real-time OS that's built specifically for Wasm to like stop any of the runtime kind of constraints like that?
Yeah. Well, one thing is, I mean, you can still ahead of time compile from Wasm to machine code. I mean, that sort of defeats some of the purpose, but there are definitely use cases where that makes sense, where I want to just kind of have this artifact to ship around, and then I know where it's going to be targeted, so I do the compile, especially if it's going to go to an embedded system, like in the case with R2S.
Bosch video.
Oh yeah. You guys should check out Bosch. There's actually like a keynote from Wasm conference that was in Seattle. Was that September? But Bosch talked at length about what they're doing in their BOSCH. The B.
Yeah, the company.
The company Bosch. Yeah, sorry.
German.
Yeah, but they're doing a lot of cool stuff with automation and PLC controllers and real-time operating systems, where they are doing ahead of time compilation of Wasm and injecting them in those types of systems. So I don't know about a comparison between running the Wasm code and just pure native itself. I would assume pure native is going to be faster, but those would be interesting
At
tests
the
to
end of
do.
the day, it becomes native code.
Yeah.
So you're saying I can hack my dishwasher with Wasm?
Absolutely.
Yeah, totally. Sure.
Absolutely.
But yeah, they have some videos where they're doing like real time like robotics or like with like PID loops and everything.
Okay.
It's pretty
Yeah.
fast.
Nice.
Yeah.
Sorry. you asked a question.
Yeah.
Is that a runtime version? Because you said like it's W3C,
Yeah.
and Mozilla.
Yeah.
I know I work with WebRTC a lot, and like,
Okay.
that has a lot of like W3C. I mean, that is a standard for that too, but
Yeah.
standard I feel like needs like big.
Sure,
runtime.
absolutely, yeah.
So yeah, so I'm just wondering like how like stable is it, or like what if one browser like upgrades it or updates it?
Yeah.
or the rest of them-
Pretty stable. I think we're on 2.0 now. Yeah, and yeah, 2.0. It's big boy.
But the core is very
Yeah, the core is stable. Now, there's some other work with other evolving standards, particularly around. If you look into Wasm system interface, and even some of the stuff going on with the component model, and that is very much in flux. I think they're trying to increase the standard there, but core Wasm is pretty stable. Yeah.
So Wasm 2.0 like just got off the presses type thing.
What is the Wasm runtime?
Well, so there's a lot of different. It depends on which runtime you're talking about. So
Like
it's a
the-
specification.
Like what?
Yeah.
The
So it,
package or whatever.
yeah. So in the browser, it's V8. So I believe that's C.
Yeah, it's like C++.
Yeah, the most popular runtime outside of the browser is Wasm time, and that is written in Rust. And there's a couple others in Rust. Oh yeah, but there's one called Wa0 that's really cool, and it's all pure Go. So the big sell there was like, you know, if you're a gopher, you don't have to use CGO to use the runtime. You have this pure Go. So it's kind of interesting that there's this, there's all these different flavors of runtime. That, you know, there's the core spec and it needs to do that, but there's other use cases where, you know, there's different flavors of runtimes. Yeah.
Has it eaten itself yet? Is there Wasm and Wasm?
Glad you asked. Actually, Ben got sucked down that rabbit hole in a meetup in Germany. I think you were digital on that one. And
Yeah, we did. It worked. We got Exosm running inside of Exosm.
yeah,
It does work.
yeah,
You have to run an interpreter inside the, it has to be interpreted, it can't, because like Wasm doesn't have a jump instruction, so you can't like JIT compile or anything, but you can interpret bytecode inside of it.
yeah,
Crisis.
yeah.
Probably, yeah.
Yeah.
There's no like vendor specific features like Safari versus, you know, Chrome versus, I mean, I don't know, there's a bunch of them. Like,
Yeah.
Not
I don't.
really, no.
Yeah.
Mostly
I don't
because
think so.
mostly because there's no, like by default, Wasm has no capabilities. So like there are no features for it to have. It's just like a calculator, basically. So you have to kind of give it features.
Yeah. And that's mainly through a lot of those imports and exports, those interfaces that you're setting up with the host. So if it wants to make a call over the network, the host is doing it on its behalf through one of these imports that it's bringing in.
What's with the
Oh.
No, go for it.
what's with the Docker desktop also now allowing Wasm? Like you would want to run Wasm inside Docker containers, or is it like gonna replace the Docker container?
Yeah, I mean that's a big topic of conversation. Yeah, I definitely won't step into that one. But in terms of capabilities, yeah, you can run Wasm in a Docker container, and yeah, there are talks about is it the new container, just in the sense of you don't have to necessarily ship around all these different system libraries. It's just the business logic, so it might even be more portable. But there's also a world where they also coexist. Yeah.
I haven't seen anyone doing Wasm and Docker together. I can't imagine what would the use case be for such a scenario.
Yeah, I think one of them I've seen is just distribution of the Wasm itself. Like there's no Wasm, there's work, like a Wasm registry in the works. Like there's a project called Warg. But other than that, you're kind of still left to your own devices and how you package up and distribute WebAssembly. So some people might just stick it in GitHub or in an S3 bucket. But some people are using OCI registries to ship Wasm around. So you might have like a Scratch container that just has the WebAssembly module. So that's one use
Like
case.
something called Docker to Wasm, and there's also one of our own projects called Hermit.
Oh yeah, Hermit's
And
cool.
Hermit's just a generic way. Instead of having like a Docker container, it's like a universal sandbox binary that you can run an application on your machine.
So you have like a binary that has a WebAssembly runtime bundled within it. So you ship the code and everything in this one artifact and have this portable binary.
Similar to something called Redbean.
Yeah, it's the same. It's got some of the same underlying architecture caused by libc.
Did Wasm 2 add the garbage collector?
I think that did just come out, right?
There
Yeah.
is a garbage collector spec, but it's not a garbage collector. It just gives the Wasm enough instructions to know how to use a garbage collector that the host might want to give it. So like if it's running in a browser, it
Bring
can,
your own
give
garbage
the
collector.
REST garbage collector.
So what is it like a kind of Zig philosophy there? Like you provided the kind of memory thing and.
Well, if you think about it, it's like objects have to go across the memory boundary and stuff. It makes
Yeah.
sense for there to be one garbage collector.
Oh, so you would give it the garbage collector that's used. So I'm guessing like on the kind of developer side, they're not passing around garbage collectors. This is more for the runtime. That the
Yeah.
runtime gives the.
The developers don't know.
Okay. Yeah, I got you.
Yeah.
Makes sense. Yeah.
Is this
Good
gonna
question.
make some capabilities of like web IDEs that are kind of like super popular, like VS Code and
Absolutely.
there's a Google one coming out, IDX.
Yep.
something like
Yeah, there's another great talk from WasmCon, that one in September. You can find all of them on YouTube. That is all about using WebAssembly with VS Code in a browser. And it's like, yeah, absolutely.
Could you use Wasm to replace Electron?
Yeah.
Yeah.
I think so.
Okay. Seem to be have a quick opinion on that.
It's like, can I use Wasm to watch my toddler doesn't
Can I use Wasm too? Yeah, go for it.
The answer is always yes.
Is anybody encrypting the Wasm on disk? So you just look at
Interesting.
Are there standards?
Yeah, that's a great
The closest
question.
thing I've seen is a company that was brilliant and was a little bit too early called, their product's called Enarcs, and it's a confidential computing. So it's like, the idea behind confidential computing is basically like, you know, when I ship my application up to Amazon, like, Amazon knows what I'm running, they can read the memory, they can read my programs, like, all that stuff is just there for them to see. The idea behind Enarcs is like, basically hiding the implementation details of the program from the actual platform. So that's kind of that's the most interesting like kind of crypto experiment I've seen.
Is that like a homomorphic something or other where you can
I think so, yeah. I don't know exactly how it works.
prove that you
I
did
think
a computation?
I think part of it is it works like it runs like a Wasm runtime in the trusted execution environment part of the chip. So you can run just pretty normal Wasm code, but other people who control that chip maybe can't get access to the computations. That's my understanding.
Yeah, that's a good question though. It's like you watched me just break apart the the source code and pull it right up. But like, yeah, I'm kind of interested in like what some mechanisms could be for like you know, digital license content and stuff like that, where, you know, maybe that's the exciting part about, I think, this ecosystem is there's still so much tooling and stuff being built around it that yeah, it's exciting. So.
What was ModSurfer written in?
Rust, I think, yeah, mostly Rust. And there are bits of it, like the parts that do the parsing of some of the sections in the module that were compiled to WebAssembly, and that's what's being used in the browser. So
Use
it's
an Extism too.
yeah,
It's
yeah,
like an Extism plugin basically.
yeah.
I haven't got your question.
No,
So you said, you know, W3C, your standards, so it's not, it won't like take them away from us, but what about the marquee tag? How do you have an answer to that? I can't use marquee tag anymore.
fair enough.
It still works on every browser.
It still works?
It does still work.
Okay, well, I got you.
I mean, that needed to go. Let's be honest. Like that was. I mean, I love it.
Browser's
Just coming back.
Yeah, that's right. No, but yeah, I mean, you know, you never know, and nothing in life is fully guaranteed. But
yeah, that was
you know,
clearly a joke.
Is there anything to the name besides the fact that it was built for the web and it is more or less byte code?
yeah, I mean, there's that whole famous quote we see everywhere, like it's neither web nor assembly. But yeah, I think the origins was that it was a web specification. It was, you know, first in the browsers, and you know, to me, it looks like assembly. I mean, you know, it's very, very, you know, for the most part.
Well, is there a projects to make? I kind of mentioned this with the real-time OS thing.
Uh-oh.
But could you have WebAssembly be the native code for a device?
Yeah.
I guess you would need
Yeah.
to extend it slightly, or would you have to extend it slightly? I guess.
I
probably not.
don't think so.
Maybe.
It's got a pretty full instruction set. I
Yeah.
think. Yeah.
Oh, but it doesn't have jumps.
Doesn't matter. I mean, it jumps. It just doesn't. It doesn't expose the concept of jumping.
Oh.
It has like restricted like control flow. Like so you can jump, but you can't jump to like any piece of code.
Oh, okay. So you'd have to like, kind of make it any, or I guess it would also, if it was the native code, then
It would just hide that implementation
Yeah.
detail.
Yeah.
everything would have to be like, I see. Yeah, that makes sense. Yeah.
Great questions. Wow. All right.
Cool, man.
Great.
Yeah.
Thank you.
All right. Thanks.
Let me shut it down.
That was it. Good.
Thanks, everybody. Yeah, our next one is in January. I guess we'll see. If it's like the day after New Year's Eve, I don't know if I'm going to do it or not.
With the talk, you said you don't have anyone for it, right?
Well, next month we're just gonna do like lightning talks, but no, I don't have anyone. If you have
should-
something.
You should show off the things that people create.
Oh, that's a great idea. Yeah, I could do some X's and stuff. Thank you. Yeah.
Are you going to create something?
Sure.
Are you signing up? All right.
You're hired for our marketing team. Thank you. But yeah, next time we'll just do some lightning talks and hang out. And if it's like the day after New Year's, then I might push it like a week or something. We'll see. But anyway, stop in the stream. Thanks everyone for coming.